Alright, so in this video, we're going to go over the Meissner effect, or levitation of a magnet over our YBCO pellets in, again, this YBCO superconducting lab that we have in MSE 407. So, as always, let me kind of run you through what's needed for this part of the experiment. So, since this is the Meissner effect, and since we are looking at levitation or effects below the critical temperature, we're going to need some liquid nitrogen. So I have liquid nitrogen in a dewar here. And to handle that safely, we're going to need some cryo gloves. These are rather large gloves. And we're going to need a shield to protect our face for that. Besides that, we're going to need our pellets. So I've got some pellets here. These are sintered YBCO pellets from a previous year. I also have several types of magnets. These magnets we get from K&J Magnets. Their website is very useful for getting some of the information for calculations that will happen later. But the ones that we'll be using in this experiment are the 1/8 inch cube magnets. This one is N52 and it's a gold color. There is also another 1/8 inch cube magnet that's N42, and this one is nickel, so it's a silver color. And then the last one we're going to use is a 3/16 inch cubic magnet, and that's N42, and that's also nickel. All right, so the last couple things that we're going to need, we are going to have some plastic tweezers for handling the superconductors, especially when they are cold. And we have a setup here, hopefully that you can see this. We have a ring stand with a clamp, and it's holding a plastic ruler. We specifically need a non-magnetic, so a lot of our rulers are metal, so we can't use them. So we have a plastic ruler basically attached, and then a little platform that we can put our superconductor on to measure how high the magnets levitate over the superconductor. Other than that, the last thing we kind of have is we have a insulated bowl. So this is just a styrofoam bowl for putting some liquid nitrogen so that we can cool down our YBCO pellets. All right, so in this video then I'm going to show you how to use all these equipment and materials, and we are going to again levitate our magnet, and the goal of this is to observe some of the properties as these magnets levitate, and also to measure the height. So we are going to take pictures for each of the pellets that we produce during this lab, levitating specific magnets above it, and we're going to take pictures of that, and we've got this ruler as a background so that you're going to be able to measure using image software like ImageJ how high the magnet levitates above the specific pellet. And that's kind of the one deliverable you'll have from this section. Otherwise, I want you to kind of note some characteristics as we levitate these magnets over the superconductor. All right, so step one, I've got my helmet on, and I'm going to put on the gloves. And the first step is going to be to pour the liquid nitrogen into our container so that we can cool down some pellets. So that's the first step I'll do here. There's quite a bit of liquid nitrogen here. I'm going to carefully pour it in. We don't need a lot. We just need enough to cover the pellets. And we have plenty more if we ever need to do that. So I'm going to close this back up so it doesn't evaporate as much. All right, so we have, as you can see, it's kind of steaming here. That's the nitrogen as it evaporates off this liquid nitrogen. And so basically we are ready at this point, let me get this set up a little bit, to cool down some magnets. So basically what we're going to do is we're going to use the tweezers, and we're going to pick out the pellet that we want to look at. So I'll pick one of these bigger pellets, and I'm going to carefully place it in the liquid nitrogen. So it might be a little hard to see that with the boil off, but I'm going to let it keep going until I stop seeing gas come off of it. There you go, you might be able to see a little bit better. And I'm going to get my setup here to measure the height. And so while that's cooling down, why don't I go ahead and grab one of these magnets. So we have them labeled in their specific vials so that we can keep track of which one is which, so we don't get them mixed up. And so you'll also want to be careful about grabbing one of these. And so I'm just going to peel off one of these. This is the 1/8 inch. You might be able to see that. You might not, okay, you can't see that very well. So that's the 1/8 inch N42 nickel magnet. So I've got that laying out here. And so it's ready to go. And so let's check on the YBCO. All right, so you can see it here. And we can just go ahead and put the magnet over it and see what happens. All right, so I don't know if you can see that super well yet, but it is levitating over the pellet. Oh, and then you saw it just stop. And so you might notice that there's a color change as this goes from one state to the next. So kind of pay attention to the color of this as well, and the physical appearances of the pellet. I'm going to stop the video and get reset up so that I can show you a better view, closer up view of the actual levitation. All right, so we're back. I tried to get a better view of the setup here so that you can see the levitation. And so I'm going to pull out the YBCO pellet from the liquid nitrogen again and move it over here so that you can see it. And again, all of that is gas into gas. And so again, I'm going to float the magnet on it. And so you can kind of see it. It's a little out of focus. I'll see if I can move it back a little bit. And so you can see that magnet moving, right? Because it's levitating, so there's nothing constraining it from rotating. And so it's actually free to rotate around and around, and I can actually spin it. And then you see that it falls, right? And so there's actually a corresponding color change as the pellet becomes lighter. It's cooling off because it's no longer at liquid nitrogen temperatures, and so it's no longer below the critical temperature. And so I can reset and do this again. So I'm putting the pellet back in. So in this setup, we have in order to get a good measurement of the height for this setup, and this is what you'll see pictures of, we have a limited time frame to work with it because it's going to cool off because it's just an ambient air. If you build the setup a slightly different way, you might be able to have it in liquid nitrogen so it lasts longer, but I want to make sure that you can see the height really well here. And on the pictures, hopefully the scale bar comes out a little bit clearer than what you see here. Okay, so let's give this another shot. All right, so it's out again. And again, you're able to see the magnet rotating because there's nothing constraining it. I can also push it and it'll go to the side, right? If I push it over, you'll see that it actually falls off, right? So there's a limit in terms of how much, the area in which it's expelling the magnetic field, but I'm able to move it around inside. And pretty soon you'll see here the color change and it's going to drop. All right. Let's do it one more time. see if we can make some more observations. So another thing that you might make a note of is that this cube magnet might not float exactly parallel or in the same plane as the YBCO. It might be sort of off axis a little bit, and so it's useful to know where that is as well, and just make some general observations about the magnet. All right, we'll put it back on. The other thing I want to note here is that I can kind of gently place the magnet, but also if you put some force on it, it will lower the magnet. So you got to be careful when you're measuring the height here. So you want to make sure that you very gently place it down so that it's not going below the height for this magnet. So you can see here it's floating, and you can kind of make some observations here. It's pretty stationary, and it's actually fairly flat to the magnet. And then you can see that color change, and it goes off and it's no longer able to superconduct. So you have a kind of window here in which you can do this as it's not cool enough at room temperature. So this is the kind of experiment that you're going to have done for the height. So basically, again, I want you to make some observations about what's happening, and then the main thing will be that you'll look at the height over the YBCO pellet, and you'll measure that, and we're going to show some calculations about what that means, what the height above the superconductor means, and what that tells us about the YBCO. So let me go ahead and instead of using this big YBCO, I'm going to get one of the smaller pellets that we have, so you can kind of see the small size. I'm going to put that in the liquid nitrogen, and we'll try that one and see what happens. So I'm still using the same magnet. All right, let's give this a shot and see what happens. All right, so I've got the cooled down YBCO, and I'm going to place the magnet above it. All right, there you can see it. So you can see the pellet's a lot smaller, but the magnet is still levitating. And again, it'll have the same issue if I get it towards the side, it'll fall off. So it's harder to place this magnet on the pellet. Right. And it looks like it's cooled down and we no longer have any superconductor. So I can do it again, one more time. Let's take a look at what this does. All right, try it again. Oops, same thing. It's a little harder to place because the pellet's relatively smaller. So I'm having a little difficulty here. Oh, and now it's cooled. So you can have some difficulty with these smaller magnets, which is why we've made some bigger ones to go along with the smaller pellets. All right. So hopefully I have a better chance. I might actually flip it over and see if that helps. There you go. You can see, oh, it was right on the edge. It fell off. It looks like it might not be perfectly flat, but you can see here that it's going, but it's not perfectly flat on this. I think there might be a little piece on the bottom of this pellet, and so it's actually coming off pretty easy because it's basically sliding down the pellet. All right, so that's basically it for the levitation. This phenomenon is known as the Meissner effect. What you're seeing here, the levitation of a magnet. This is what's used for maglev trains and so forth. And again, the kind of deliverable that you'll see here in the video or in the photos in your data drive is you'll see the heights. You'll see pictures with the heights, and your job is to determine the height based on some image analysis, and then obtain that height, and we're going to do some calculations to see how good of a superconductor this is relative to how high the magnet will levitate. So that's it for the levitation experiment.